Hello everyone and welcome to Sally and Bytes. Let's work out these NCERT problems, functions in Python, Part 1. Question 1. Subdivision, A. Observe the following programs carefully and identify the error. Now, look at the given code. In line 1, this code defines a Python function named create that takes two arguments, text and frequency, and then in line 4, call that function with a single argument 5. However, there are a couple of errors in the code. In line 3, missing print parentheses. In Python, the print function requires parentheses around the arguments you're printing. In your function, you're missing the parentheses around text in the print statement. In line 4, we are trying to call the create function with a single argument 5. However, the create function expects two arguments, text and frequency. To clarify, the create function should be called like this: create hello world of 5. Here, hello world is the text argument and 5 is the frequency argument. The corrected function call matches the function's parameter requirements. Thus you can see the corrected code with the output on the right side of the screen. In this corrected code, the function create takes two arguments, text and frequency. It then prints the provided text for a specified number of times, frequency. The function call create hello world of 5 will print the text hello world 4 times, as the range is from 1 to 5. Question 1. Subdivision, B. Observe the following programs carefully and identify the error. Now, look at this code. There are two errors in the given code. In line 1, missing import statement. We haven't imported the cos function from the math module. In Python, functions and modules need to be imported explicitly if they are not part of the built-in functions. Since cos is a mathematical function, it must be imported from the math module before you can use it. Second error is the incorrect function call syntax. We are trying to use the cos function as if it's a built-in function without the proper import statement. In Python, function calls require parentheses around the argument list, but we haven't used parentheses for the print function call. So, you can see the corrected code on the right side of the screen with output 1.0. Question 1. Subdivision, C. Observe the following programs carefully and identify the error. Now, look at the given code. There are two errors in the given code. First error is the variable scope error. The primary error is related to variable scope. We have a variable named mynum defined outside the add9 function in the global scope, and you are also trying to use a variable named mynum inside the function. When you attempt to modify mynum inside the function with mynum equals mynum plus 9, Python treats mynum as a local variable within the function. However, it hasn't been defined in the local scope, which leads to an unbound local error because we are trying to reference a local variable before it's assigned a value. To fix these errors, you can use the global keyword inside the function to indicate that you want to modify the global variable mynum Python copy code. So now look at the right side corrected code. In line 3, we write global mynum. Here, we declare that we want to use the global mynum variable. By adding global mynum, we tell Python that we intend to work with the global mynum variable inside the function, allowing us to modify it as expected. The second error is the print statement syntax. In Python, we should use parentheses with the print function. So, print mynum should be written as print open brackets, mynum, close brackets. You can see the corrected code on the right side of the screen with output 18. Question 1. Subdivision, D. Observe the following programs carefully and identify the error. Now, look at the given code. There are two errors in the given code. First error is the default argument position. When we provide default values for function arguments, they should appear after non-default arguments. In our function definition, we've placed val1 with a default value before val2 and val3. This is not allowed in Python. Second error is the function name mismatch. The function name should match the one we are calling. In line 1, we defined the function as findValue, v capital letter, but we are trying to call it, in line 4, as findValue, v small letter. Python is case sensitive, so these names should match. Third error is in line 4, findValue function. The error in this case is due to the fact that the function findValue expects 3 arguments, val2, val3, and val1, but we haven't provided any values for these arguments in the function call. So let's correct this code. Now, look at the Python code after error correction. In line 1, we can rearrange the order of function arguments so that non-default arguments come before default ones. So line 1 becomes def findValue of val2, val3, val1 equals 1.1, colon. In line 6, let's fix the function name to match the one we are calling, findValue, capital V instead of findValue, small v. In line 6, we can provide the specific values for val2 and val3 when calling the function, but we can change these values as needed. Here, we have added 2.0 and 3.0. Now the output is 4.5455454545454545. Question 1. Subdivision E. Observe the following programs carefully and identify the error. Now, look at the given code. There is an error in the given code. The error is the syntax error. We have a syntax error in line 3 in the function call. We're trying to assign the return value of the greet function to a variable named message, but we have used the equals operator incorrectly. In Python, we should use the equals operator for variable assignment, not for assigning a function's return value. In function call assignment, if we want to capture the return value of the greet function in a variable, we should use the correct syntax to do so. You can see the code after error correction below. In line 3, message equals greet function. In line 2, we have added a print statement to just display the output good morning on the console. Question 2. How is math.ceil of 89.7 different from math.floor of 89.7? Let's see the solution. Math.ceil of 89.7 and math.floor of 89.7 are both functions from the Python math module used for rounding numbers, but they behave differently. Math.ceil of 89.7. This function stands for ceiling and it rounds a number up to the nearest integer that is greater than or equal to the original number. In this case, math.ceil of 89.7 will return 90 because it rounds up to the nearest integer that is greater than or equal to 89.7. Math.floor of 89.7. This function stands for floor and it rounds a number down to the nearest integer that is less than or equal to the original number. In this case, math.floor of 89.7 will return 89 because it rounds down to the nearest integer that is less than or equal to 89.7. So let's recall, math.ceil of 89.7 rounds up to the next higher integer, 90 in this case. Math.floor of 89.7 rounds down to the next lower integer, 89 in this case. Question 3. Out of random function and randant function, which function should we use to generate random numbers between 1 and 5? Justify. Let's see the solution. We should use the randant function from the random module to generate random numbers between 1 and 5. Inclusive range. Randant function allows us to specify an inclusive range, which means that both the lower and upper bounds are included in the possible results. In our case, we want random numbers between 1 and 5, inclusive, so randint of 1, 5 will give us numbers 1, 2, 3, 4, and 5. Simplicity. Randint function is straightforward and easy to use for generating random integers within a specified range. We provide the lower and upper bounds as arguments, and it returns a random integer within that range. In contrast, the random function generates a random floating point number between 0 and 1, excluding 1. So, to generate random integers within a specific range, such as 1 to 5, randint function is the more appropriate choice. Let's see an example. In line 1, import random. This line imports the random module into our Python script. It allows us to use functions and classes defined in the random module in our code. In line 2, random_number equals random.randint of 1, 5 : This line generates a random integer and assigns it to the variable random_number. The randint function is a part of the random module, and it generates a random integer between the two specified values, inclusive. In this case, it will generate a random integer between 1 and 5, including both 1 and 5. In line 4, print of random_number. This line prints the value of random_number to the console, displaying the random integer generated by randint within the specified range. So, when we run this code, it will import the random module, generate a random integer between 1 and 5, and then print that random integer to the console. The specific random number we see will vary each time we run the code because it's generated randomly. So you can see at first we get 1, again when we run the code, we get 2, again 4, again 3, etc. Question 4. How is built-in function POW function different from function math.pow function? Explain with an example. The POW function is used to calculate the power, exponentiation, of a number. There are two versions of this function in Python. First one is the POW built-in function. This is a built-in Python function that can be used without importing any additional modules. It can take 2 or 3 arguments. POW of x, y. This calculates x raised to the power of y, POW of x, y, z. Calculates x raised to the power of y, and then takes the modulus z of the result. Second one is the math.pow function. This function is part of the Python math module, so you need to import the math module before using it. It always returns a floating point number and takes 2 arguments. Math.pow of x, y. This calculates x raised to the power of y and returns the result as a floating point number. Here's an example that demonstrates the difference between the two. In this example, in line 2, result 1 uses the built-in POW function to calculate 2 raised to the power of 3, resulting in an integer 8. In line 3, result 2 uses the built-in POW function with 3 arguments to calculate 2 raised to the power of 3 and then takes the modulus 5, resulting in an integer 3. In line 7, result 3 uses the math.pow function to calculate 2 raised to the power of 3, and it always returns a floating point number, 8.0. So, the key difference is that POW function can return an integer or a floating point number depending on how it's used, while math.pow function always returns a floating point number. Question 5. Using an example, show how a function in Python can return multiple values. In Python, you can return multiple values from a function by simply separating the values with commas. These values are typically returned as a tuple, which can be easily unpacked when calling the function. Let's see an example. In this example, the get_user_info function returns 3 values, name, age, and email. In line 5, these values are separated by commas in the return statement, creating a tuple. In line 8, when we call the function and assign the result to 3 variables, user_name, user_age, and user_email, Python automatically unpacks the tuple into these variables. In line 11 to 13, as a result, we can access and print each value individually. You can check the output on the console. Question 6. Differentiate between following with the help of an example. Subdivision A. Argument and parameter. Let's see the solution. Parameter. A parameter is a variable declared in the function definition. It serves as a placeholder for the value that will be passed into the function when it is called. Parameters are used to define what kind of input a function expects. Argument. An argument is the actual value that is passed into a function when it is called. It corresponds to the parameter in the function definition. Arguments provide the data that the function will operate on. Let's see an example. In this example, in line 1, name is a parameter in the greet function's definition, defining that the function expects a single input. In line 5, when we call greet of person_name, we provide the actual value Alice as an argument, which gets assigned to the name parameter within the function. The function then uses the argument to greet Alice. You can check the output as Hello Alice. Note that in line 2, an f-string, short for formatted string literal, is a feature introduced in Python 3.6 that allows you to embed expressions inside string literals, using curly braces. These expressions are evaluated at runtime and their values are inserted into the string, creating a formatted string. F-strings are denoted by an lowercase f or uppercase F prefix before the string literal. F-strings are particularly useful for creating formatted output because they make it easy to include variables and expressions within strings, improving code readability and maintainability. They are a powerful tool for string interpolation and formatting in Python. Question 6. Differentiate between following with the help of an example. Subdivision B, global and local variable. Global variable. A global variable is a variable declared outside of any function or block of code. It is accessible from anywhere in the program, both inside and outside functions. Global variables have a global scope, meaning they can be used throughout the entire program. Local variable. A local variable is a variable declared inside a specific function or block of code. It is only accessible within that function or block. Local variables have a limited scope and are typically used to store temporary data that is specific to a particular function. Let's see an example. In line 1, global_var is defined as a global variable with the value welcome to Sally and bytes. In line 2 to 6, the greet function is defined, which contains a local variable local_var with the value a complete guide to learn Python. In line 7, greet function is called, invoking the function. In line 8 to 10, output within the function, greet function execution. Inside the function is printed. Print, global variable, global_var, prints the global variable global_var. The value of global_var is welcome to Sally and bytes, so you see global variable, welcome to Sally and bytes, printed. Print, local variable, local_var, prints the local variable local_var from within the function. The value of local_var is a complete guide to learn Python, so you see local variable, a complete guide to learn Python, printed. Output outside the function, greet function has completed execution. In line 8, outside the function is printed. In line 9, print of global variable, global_var, again prints the global variable global_var. Since it is a global variable, it retains its value throughout the program, and you see global variable, welcome to Sally and bytes, printed again. In line 10, print of local variable, local_var, is an attempt to print the local variable local_var from outside the function. This would result in an error because local_var is defined only within the scope of the greet function and is not accessible outside of it. Since it's not accessible, the program would raise a name error. You can check the output on the console. Question 7. Does a function always return a value? Explain with an example. In Python, a function does not always have to return a value. Whether or not a function returns a value depends on whether you use a return statement within the function. If a return statement is used, the function can return a value, but if there is no return statement, the function implicitly returns none, which is a special value in Python representing the absence of a value. Now, look at the Python code. In line 1 and 2, function definition, no_return_ function. We define a function called no_return_ function. Inside the function, it prints the message this function does not return any value. In line 4, 5, and 6, function definition, return_function. We define a function called return_function. Inside the function, it prints the message this function returns a value, 42. It then uses the return statement to return the value 42. In line 8, 9, and 10, function definition, bake_cookies. We define a function called bake_cookies that takes two arguments, cookie_type and quantity. Inside the function, it prints a message indicating the type and quantity of cookies being baked. It then uses the return statement to return the quantity of cookies baked. In line 13, 14, and 15, calling the functions. We call the no_return_ function without passing any arguments. This function prints its message but doesn't explicitly return a value. So, result 1 receives the special value none. We call the return_ function, which prints its message and returns the value 42. Result 2 stores this value. We call the bake_cookies function, specifying that we want to bake 24 chocolate chip cookies. It prints the message and returns the quantity, which is then stored in the cookie_count variable. In line 17, 18, and 19. Printing the results. We print the results. Result of no_return_ function. None, because no_return_ function didn't return a specific value. Result of return_ function, 42, because return_ function returned the value 42. We baked 24 cookies in total, because bake_cookies returned the quantity of cookies baked, which is 24. You can check the output on the console. Thanks for watching. Watch the upcoming videos. Subscribe to my YouTube channel to stay updated with engaging content and never miss out on my latest videos.